Let us now look at the equation of normal to an ellipse. So we'll be looking at the point form and basically the parametric form, or normal at a point a cos theta b sin theta. So the steps are very simple. You will first have to differentiate this, get the slope of the normal of the tangent, right? That's done by differentiation and putting collecting the dy by dx terms and putting x1 y1 in the expression. That will give you this, which is basically the slope of tangent. Slope of tangent into slope of normal is -1. So slope of normal can be got as 1 by minus 1 by slope of tangent, which is this. So now you have the slope of the normal. So you have the slope of this pink line, and you also know it's passing through x1 y1. So you can use the slope point form to get the equation of the normal. That's all that we do. And the final expression that we get is this, the equation of the normal at x1 y1. There are multiple ways you can derive this. So what you can do is you can write the equation of the tangent straight away using s1 equal to 0. You will get the equation of the tangent. From there you can get the slope of the tangent. Then you can get the slope of the normal as -1 by slope of the tangent. And then you have the slope of the normal, and then you also have the point. You can use the slope point form to get the same equation. Whatever it is, you will first have to get the slope of the tangent, and only from there you can get the slope of the normal. Coming to the normal at a point a cos theta b sin theta, or the parametric form of normal. So we already know that every point on an ellipse can be represented as a cos theta b sin theta. So instead of this x1 y1, I can replace it with a cos theta and b sin theta to get this as my final expression. There's nothing complicated about this as well. You just have to put a cos theta b sin theta in this equation to get this equation, which is basically the equation of a normal in the parametric form. With this done, let's look at what are co-normal points. Let us try to now understand what we mean by co-normal points. So from any point in the plane, at max 4 normals can be drawn to an ellipse. If you remember, for a hyperbola, the number was 3. That means for a parabola, not a hyperbola. So for a parabola, from a point outside, you could draw at max 3 normals. At max 3 normals to the curve, right? So the important line here is from any point, right? Don't forget that it's not at any point. At any point, only 1 normal can be drawn. But from any point in the plane, a maximum of 4 normals can be drawn to the ellipse. So for parabola, the number is 3, but for ellipse, the number is 4. These 4 feet are called co-normal points. So basically, if you have an ellipse, and from any point outside, if I can draw 4 normals, so this is a normal, for instance, this is a normal, and likewise you have 2 more, this is a normal, this is a normal, right? So these 4 points, which are basically your A, B, C and D, these 4 points are called co-normal points because they are starting. These normals are intersecting at a single point outside. They are all coming from one point. That's why they are called co-normal points. This is the condition for co-normality. You don't need to derive this. It's a lengthy derivation. But what you need to understand is this is the what is alpha, beta, gamma, delta. These 4 are the eccentric angles, right? What do you mean by eccentric angle? For example, your A has an eccentric angle alpha. That means you have the ellipse here. On this point, you have A. You will take the auxiliary circle around this, and you will go up this point. If this point is A, then this point on the auxiliary circle, this will subtend an angle alpha, right? Not A. A won't subtend angle alpha. This point here, which is on the auxiliary circle and perpendicular to perpendicular to the major axis, and in that direction of A, then that point subtends an angle alpha. So you have 4 points and their eccentric angles. Their eccentric angles must be an odd multiple of pi. That is the condition for your 4 points to be co-normal points. So with this, this is the only result that you need to remember about co-normal points. Let's move on to the next subtopic.